Hello
Good morning, good afternoon.
for whoever and wherever you're calling it from. Um, we got a live stream. We're doing a live stream. This is Jim and I's first live stream we've ever done together,
Yay.
and I am so excited to be joined by Jim today. We were talking yesterday. I think Jim's actually going to be teaching me some new stuff about TinyBird today, so we may
Fingers,
all just learn a little something.
yeah, fingers crossed. And
Fingers
likewise,
crossed.
Joe, I know I'll learn from you as well.
I don't know about that. But we'll see what happens. It's early morning for us. It's Tuesday, January 9th, and today is build real-time products over Kafka. Is that what the title of this talk is?
Sounds right.
Let's see here. Let's do a quick introduction, and then let's talk, just a quick overview of how this stream is going to work with everybody and what we're going to be covering today. I guess I'll go first. Well, I don't know. Maybe I'll do a broad intro for us, and then Jim, you can fill in any blanks here too. With any,
Okay.
give us a fun fact or something. But
sounds good.
Jim and I were developer advocates. We work for TinyBird. TinyBird is a OLAP real-time database, and we specialize in making it super easy to use your data, especially real-time data. Jim and I started about the same time. We've been here for about 8 months now, almost a year. It's been an amazing year. I've loved working here. It's been amazing building cool stuff. I've been in the database space for, I don't know, quite a while now. I've worked in big database companies. And Jim is Twitter.
Yeah, now you can say XX.
XX. Oh, I like that.
No, I prefer the Twitter term. Yeah, hi, everybody. Yeah, as Joe said, joined last April. And what drew me to TinyBird were the words real-time data and streaming. At Twitter, I was on the dev relations team supporting, all their products, including their live stream. So TinyBird seemed like a good fit, and it's certainly proved out that way.
Oh, I love that. And if anyone's a weather nerd.
Yeah, my background's in flood warning systems and weather, and it's like my favorite use case for any type of data platform because it's like this agnostic public data that you can work with, and most people have at least some interest in weather, so it's a neat area to be a developer advocate with that background.
I love that. It's always a great data source to play with too, which is always the hard part with our jobs.
Yeah, exactly.
Lots and lots of data, always changing, and needing to always be up to date.
Mm-hmm.
It's snowing this morning where I'm at, and I wish someone had alerted me earlier. I'm sure someone did. I just didn't pay attention. But
lucky you. I love snow.
Oh, it's beautiful today. Hate shoveling. Love snow. That's great. Okay, cool. So today, let's talk about what we're going to be doing today, Jim. We're going to be building out an app for you today. So this is a real-time scooter app. Think like a Lime or a Bird or another real-time scooter rental app. But we'll be building out the customer-facing side of that. So I think for apps like Uber, Lyft, and these scooter rental or bike rental apps, it's really important to get real-time updates on where the bikes are at, if they're being used, and what the battery level is on those devices. If any of those are out of date, that is incredibly frustrating from a user perspective, which I think makes this a really fun demo. But we'll be doing a couple things with that. We're going to be connecting up to a Confluent Kafka cluster and streaming in real-time data from a data generator we built in Python. We'll be creating some pipes from that and hydrating a retool front-end dashboard so we can kind of build out a mock prototype scooter rental dashboard from that. And then Jim's going to be helping out with building out deduplication and increasing the performance of our pipes by making some materialized views from all this mass amounts of data that we're streaming in.
Right. Yep.
Jim and I were looking this morning. We have 17 million rows of data currently saved, and we're going to be generating even more during this talk today.
Yeah.
And then, so we'll have a lot of data to play with. And then lastly, we'll be going through, and I'm connecting up an S3 CSV file saved in S3, and then we'll be importing those into our app and making some new data insights from that. We're going to be treating S3 like a data lake, which is a really common use case.
Right.
I think today's focus, Jim, is going to be more on the optimization end of things. If you tuned in last time and saw this app, awesome, welcome back. We're trying to mix it up a little bit here too and try to give a little bit more depth and meatiness to creating fast, efficient, and affordable real-time apps using SQL and Materialized Views and kind of understanding how it's working underneath the scenes. Did I cover everything? I feel like
you did. Yeah.
I feel like that's it. The last thing I'll say too is Jim and I are keeping an eye on the chat here too. Looks like Alexis. Thank you so much for coming, man. Oh, and Alexis is asking if we're going to have the Python scripts available today. And the answer is yes, we will.
Yes, we have a repository up on GitHub, and we'll have all the scripts in there, or the one script in there.
Yes, you tell you what, I'll post it right now to the chat for you, Alexis, while you're here.
Nice.
Let's see here. I hope that's the right one.
And while Joe's doing that, I think today the cool thing is we're going to be working around a very common use case where you have vast amounts of real-time data streaming in, and then you have dimensional supporting metadata. You want to mash up those two. You want to join those data sources.
Yeah,
that is sort of a classic use case for TinyBird. And this whole scooter app, I mean, I think it also extends itself to any location-based logistics type exercise. So it's a fun use case to play with for sure.
It really is. Yeah, it really is. And we got Andres. Did I say that right? I hope I did. Reading is not my forte. I can hardly read. But we got someone from Berlin joining us today. That's awesome.
This is awesome. Woo! Viewers from around the world, different time zones. I love it.
I love the comments. Anyone who's joining us today, flood the chat with comments. We love to hear them. We'll be answering questions the entire chat. We'll also be having some time at the end for questions. But Jim and I just kind of prefer kind of answering questions while we're in it. So if you guys have something, go for it. We'll try to answer it right away. Also, just note, it's really hard to code and keep an eye on the chat, so we're going to try our best. So if we ignore you for a second, don't be sad. We'll get you soon. All right, cool. Jim, what do you think? Should we jump into some slides here?
Yeah, we're going to start off with some introductory slides.
Everyone's favorite. Everyone loves this. Everyone loves a slide.
That's right.
Let's see here. Is that still show up? Great.
Looks great.
So the first thing I want to do is actually define what real time means. I'm sure if anyone's been in the space, and if you're joining us for a TinyBird live stream, you've probably heard the term real time tossed around. Between you and me, I think it's a jargony word that borders on meaningless. But I think it helps define what TinyBird means by real time. I think that we have 6 categories of real time analytics. Let's break that down. So when we're discussing real time, we have 2 facets, which is going to be freshness and latency. Freshness has to do with how fresh the data is coming downstream. So if you have data lakes, or in this case, we're using Kafka streams, you're talking milliseconds. The data is going to be just piped right in. It's going to be milliseconds old. And the key part, too, for a lot of OLAP real-time database engines is the latency. That's the part you can really control with your analytical engine. And that's how fast the queries take to analyze, right? You have a billion rows of data. Does it take milliseconds or hours to run those queries? But we think that real time should be in the millisecond zone when you're doing those kind of queries at scale. All right, so next up, real-time analytics. So a common part too with analytics is the query complexity. And I think that gets complicated because when you're doing analytics, typically you're joining lots of different facets of things that aren't stored traditionally in your transactional database. You want to get like mass analytics on that. So that means you're pulling in lots of different data sources and doing lots of joins and complex aggregations on that data. Today, we're going to be showing you how to do a combining S3 data lakes or just data lake in general with real-time data with Kafka, which if anyone has ever done it before is pretty difficult. It involves a lot of work, servers, lots of Python, and building that out. And lastly, too, is historical data. Having massive amounts of old data to kind of analyze is really important. I always love to give the example of an e-commerce store, too. Like, for example, if you're working on Black Friday and you want to see how you're performing last year's Black Friday, having that historical data is essential for doing real-time analytics. All right. And then lastly is concurrency. So this is the at-scale components. In TinyBird, this is something we do really well. Building out real-time internal analytics is one thing, right? It's maybe just a couple people. You may be running a query once a day, once a week, once an hour. But if you're building user-facing analytics, you need to make sure that your database engine can scale to massive concurrency, which is a breaking point for a lot of engines. But we believe real-time analytics at scale should have that component as well. Okay, cool. So, Jim, now we've talked. We have a baseline here. What we're talking about real time. So I hope everyone's on the same page.
Yeah.
Great.
Yeah, I think just to stress, I think one important thing, and one thing I've learned a lot about after joining Tinybird is the concurrency thing. A lot of data lakes, a lot of data storage engines out there are fast, performant, but when it comes to serving, imagine thousands of concurrent requests, a lot of times those type of engines sort of just become a bottleneck, and that certainly is not the case with Tinybird.
100%. And let's see here, Jim. Looks like you replied to Alexis' question too. I'm just going to pop this up real quick. Alexis is asking about Confluent Kafka clusters and whether the setup is going to be the same for MSK in AWS, which is basically AWS's version of Kafka. And the answer is mostly yes. So the only difference is getting the data out of MSK is a lot harder in AWS. I think by default, it's locked into the AWS ecosystem. So it takes a lot more work to make that more public and open that up. But Tinybird's Kafka connector is a generic connector, can connect to any Kafka streams. That means Red Panda, Confluent, MSK, any stream you could throw at it, we can accept out of the box. But some downstream configuration might be needed for MSK to kind of expose that data publicly. All right, cool. So, Jim, should we talk about what we're going to build real fast?
Yeah.
I feel like time's flying here. It's already like 15 minutes in. Thanks for everyone for hanging out with us, though. This will be fun. We got a lot of cool stuff to build. But speaking of cool stuff to build, we're building the real-time scooter app. So this is a scooter fleet application. So you're managing and viewing scooters at scale from around an area. So again, we're going to be using Confluent Kafka to stream in that data using our data generator. Actually, maybe I'll just go to this next slide here, where we go through the
data flow.
The data flow, yes. So we're going to be using. This is all mock data. Obviously, Jim and I don't have a fleet of thousands of scooters out in the field.
Not yet.
Not yet. I know that's Jim and I's next business. So if anyone wants to join us, please.
Yeah, we're going to need your help.
But we're sending about 1,000 events per second, and this is just handling on my single machine. But this can scale up to much larger workloads. We'll see that in real time here today. But we'll be piping in these events from a Python script, which we linked above, and we'll post that link again to the code. It's all open source. And then we're going to be streaming all that data into Tinybird. And then we're going to be building out. Today's just going to be building the user-facing app, but you totally could build out more APIs and kind of do more of a business end piece of that. And then lastly, the scooter dimensions data. It's kind of like scooter info. That's going to be hydrating from S3 data. It's CSV data saved in S3. So we'll be going through these pieces today, everything except for the business app we're going to be building out today. Let's see here. We got a lot of Germans in the chat today.
Yeah.
We cover restricting stream access based on user authentication. We will not be covering that today, but we could totally cover that. That's a super common use case and something we recommend people do. We have some guides. I'll try to find them if I get some downtime during the stream today and post in the chat. Otherwise, feel free to join the Tinybird community. It's a great place to ask that too, and we can for sure hook you up with that information later on too. But we have a Tinybird Slack. Just go to tinybird.co and join our Slack, and we'll get you all the information you need about multi-tenancy. Again, very common use case and pattern we recommend. Okay, let's see here. I think that's enough. Did we do enough groundwork there, Jim?
Yeah, let's build some data sources.
Let's build some stuff. Okay. So I've already built out a little. Let's see. I should make this bigger so people can actually read what's going on here.
Yeah, that's good.
So we have an empty Tinybird workspace. If you're new to Tinybird, this is the UI for kind of interacting with it. We do have a CLI. You can interact with this with Git. You can save and persist all your files and text. But we're going to do everything in the UI because it's prettier and easier to show on a live stream. So first thing we need here is we don't have any data. We probably need some data. So the first thing we're going to do is actually import our Confluent stream. So you notice here we have our Kafka stream. This is where we do MSK if you're using that. But we have a native Confluent connector, which is great. Yeah, I already connected it. Oh, that's great. I already put in the events. I usually delete the connection, but we have our Bootstrap server already set up and ready to roll. So I'm going to find my topic called
it's there.
Scooter. Always a good sign. And I'm going to we have a choice here to just do the new events or earliest events. I have the Confluent cluster up here. And actually, I'm going to start running the data generator now, just so we can start seeing it. But what's going to do, you have a choice of whether you're going to be importing everything from the beginning or just the new things. Jim and I want to have a lot of data to play with today, so we're going to be bringing in from the beginning of time. All right. And a couple things to note here. You can change the name of it. You can bring in header files from your Kafka messages, and you can choose all of the different events or the key value pairs that you want to import in here. The other thing too you can do is change the type of the column that you're importing as well. Tinybird is a really great guesser. We make some like sane guesses of what the data type is, but if you want to override that with your own data type, this is the time and place to do it. The other thing you can do too is change the engine sorting key. Jim's going to be showing us how to do that after the fact today.
Yeah.
But we're just going to leave it by default. And we're going to just hit create data source and everything will be imported in. So let's let that go. I have the data generator running right now. Let me double check to make sure that's good to go. Yep, should be good to go.
Yep.
I'm going to refresh over here. So there we go. Now you can see we got 99.4K, 99.4 thousand bytes per second are being imported in. And then we should see that here. It takes a refresh here on the Tinybird side, but once we give that a refresh, then we should start seeing those data in. Or maybe just another couple refreshes and it'll start coming in. Sometimes it takes a second, but it is importing all. What is that?
17 million, I think.
17 million. Yeah, we had a lot in there. Consumption last hour, just almost 400,000 total messages. I think it's even just like the last day. We have a lot more. All right. Well, let's see what happens here. Should be going in just a moment. All right. Well, we have a connection. We might be able to still set this up.
Yeah, I was going to say I can start building our first data analysis pipeline while that data. I mean, we're seeing the confirmation there at the bottom that the connection has been established. We know we have the right topic. So
yeah,
it's a matter of just in that 17 million reports to flow in.
Absolutely. I think it'll be here in just a moment. And then Jim is I'm going to share Jim's screen here. Jim is in the same workspace that I just had up here. It's the same exact workspace, which is really nice. We're going to show like how to kind of collaborate on that in one way, kind of how we're building that together.
So I'm going to build our first.
We have a question real quick here.
Okay.
Do you mind before we jump in? Alexis is asking, he has a question about the schema in Kafka and why we did not use a sorting key. Good question. The answer is we're going to be adding a sorting key in just a little bit. But if you know what you're going to be querying on often, adding a sorting key up front is a really great idea.
Yeah, it's definitely worth thinking about that as you set up your data sources. Typically you have a good idea of like what the type of queries and endpoints you're going to deploy, what's going to be your, a lot of times it's simply the timestamp, but you probably have other attributes that you're going to be pulling out. So yeah, it's a good idea to put some thought into your sorting keys as you're defining your data sources. So I'm going to build our first pipe. So I went to the UI there and selected that. And we're going to call this nearest available scooters. And as the name implies, you can guess what we're going to build here. We're going to build 3 nodes here. These pipes are a lot like, you can think of them as like Jupyter notebooks where you have multiple nodes. Each node has SQL in them. And you can chain them together so one node can build off the one before it. So I'm going to create our first one. And it gives a default name based upon the pipe name, but I'm going to call this get latest data or get latest events. All right, so then I'm going to build this query, and it defaulted to the one data source that we have. And one neat feature of Tinybird is anytime you're working with these data sources, of course, it helps to know what schema you're pulling from. You can click on this. You can always get a view of what's there. You can review the schema that you've set up. And here you do see that this sorting key was set to the timestamp of the data coming in. So let me close that. Let's write our first query here. So I'm going to do a select all. And what I'm going to do here is I'm going to build these 3 nodes just without any fancy stuff in them. And then we're going to go back and make them dynamic parameters for the app that we're going to put together. So I'm pulling all the events from that table, and I'm going to order by timestamp descending because we want the most recent data first.
Mm-hmm.
And then I only want the latest from each scooter. So I'm going to do a limit 1 by scooter ID. As you can see, as I'm typing, we have these helpers that pop up, just confirming the different names of the data source. I'm going to run that. Oh, we don't have any data yet.
No, I know. I was just trying to figure that out behind the scenes here.
Yeah.
I don't know, because it's weird because it's flowing into Confluent. I'm seeing the new messages show up in there.
Okay. I mean, I can continue building these pipes and then.
Yeah. I might delete the topic and then re-add it and see if that fixes it. I'm not sure what's going on. Is that okay? It may die in you for a sec here, but
yeah, that's fine. I was gonna say maybe we could just tear it down and recreate from scratch.
Yeah. Keep going. Like I'm not here, but I'll rebuild it in the background.
All right. So now I'm gonna build my second node, and this node is gonna filter by the amount of battery that's in these scooters, because obviously we don't want to make a scooter available for rental that has a certain low battery voltage. So I'm going to make this next one. I'm going to call this, what should we call it? I'm going to call it filter by battery. By battery percentage, percent and available.
Mm-hmm.
If I could type. All right, so let's build this one out. And you can see here I'm pulling from the previous node. So that's, again, just a feature of Tinybird. Usually you want to build your queries step by step. You don't have to sit down and write one master, huge, complicated query. You can kind of nibble at your transformation one node at a time. I'm gonna, let's see here. I'm gonna select things like scooter ID, and in this pipe, we're gonna be calculating distance. So I need the latitude for each. I need a longitude. It's good for now. And let's build a where clause. And I'm gonna make this pretty simple right now. Where battery percent. Let's say I wouldn't want to rent one that has anything less than 50, but we'll make this a dynamic parameter in a minute. And then the final where clause is, of course, we want a status of the scooter that's equal to available. All right, so let's run that. Again, I'm not going to have any data, but
yeah, it's still not up. It's in our working repo, but I don't see it in our old one. It's just sending the new data, which is so weird. I got one. I'm going to delete the entire thing.
And while you're doing that, I'm going to build the third and final node here. And I'm going to call this one. This is going to be our final one. So one convention is just to call it endpoint, and you'll see why in a minute. When we go to publish this, it gives us a list of the nodes in this pipe. And this one just makes it super simple to know which one you want to actually publish. So let's, I'm going to do the same attributes. And this thing's going to have one new feature. I'll be calculating a distance. And this is the one line I'm going to copy in just because if I'm going to mess up one line, it's going to be this one. What we're doing here is we're going to make it so you can pass in a user location, and then it's going to calculate a distance from that point to all of the locations of the scooters. And here we're just doing a simple square of the powers, define the distance. And here I'm just assuming the user location of 36 latitude and minus 115.3 for longitude. And then we're going to want to sort this by distance. And we want that to be ascending. We want the closest first. And for now, I'm just going to do a limit 10. So it's just going to pull back the 10 closest scooters. So now we're just back to the the need for data.
Yes, I deleted the connection. I re-added it again. Still nothing. It's showing up in our working one. Jim, I'm wondering if we should switch over to the other the other workspace.
Okay.
Is it possible to copy that over the code there? Kind of.
Can
you create like a notepad and save that over, and then we can?
Yeah, I can do that. I mean, I have that ready to roll.
I'm not sure what's not showing up in this other one. So, okay, cool. Yeah, it's still not showing up. I deleted the connection and re-added it. Saw the data was in there, and then it's just not importing it. Let's switch over to the other one, okay. And we'll deal with that. Let's see. Alexis is asking a question. Maybe while you're importing, I'll deal with this question.
Sounds good.
Alexis, why can't we make APIs from different nodes yet? And why do you need to create a pipe for each API? This feature could be really useful, as sometimes I need to create more pipes to use the same nodes. So the question is, why can't we make APIs from different nodes? Create a pipe for each API. Oh, we have to create a pipe for each API. Yes. It's honestly just best practice. So we like to differentiate too and kind of split things up into more discrete nodes and chunks. So there's some duplication, but if you do want to repeat like nodes, which we'll be showing today too, with like, we're going to be getting the latest telemetry events from the scooters. You'll be able to do that and then share that common node along with other ones down the line too, to kind of save retyping or kind of have a common function to use too. So you can reuse nodes on API nodes, but it can be really useful too for like, especially if you're publishing an API and it's public, you probably don't want to mess around with like the query too much, or at least the kind of how it changes. So we suggest keeping those separate if possible.
Yeah, and the fact that you can, like, from a second pipe, you can refer a node in the original pipe, and that way you can sort of mimic that behavior.
Yep.
Do you want to switch to the other one, or what?
Yeah, that's what I think we should switch to the other one. I am at the end of my live stream troubleshooting abilities.
Yeah, I don't quite get that.
So you should have access to the other repo, Jim. Yeah, you want to. So if you it should.
Here, I'll switch to your screen.
Oh, okay. Let's see. I don't have any of the code you just wrote.
I know.
You want me to do it? You want me, or do you have it?
No, I'll do it, but for display purposes.
Okay, maybe easier because you should have access to it.
Okay, let me.
If you click on Tinybird Live in upper left hand, there you go. Yeah.
So you're saying that this one is live and ready to roll.
Yeah, and if you see it's getting data there on the far right, the data's flowing in here. It's the same.
And one quick way to check that, I do this a lot. We have this new feature called Playgrounds. I'm going to go in there, and what this is just like a pipe, although you would never publish. You can't publish an API from this, but it's a great way to explore your data. So I'm going to copy in a query here. It's just going to pull out the most 10 recent reports in our data.
To see if it's fresh.
Yeah. Yep, that's pretty fresh. In fact, I'm going to just pull out timestamp just so it's better visual.
Oh yeah, good idea.
And this could be like your internet clock. Here you can see current data coming in every few seconds. Yeah, like about every 5-6 seconds. All right, so
it's working. I don't know.
We got data coming in. So this was the same. Okay, this is perfect actually.
Yeah.
This is where I'm going to go back to our original data source here.
Okay.
This is the final version, so we're kind of skipping ahead. But this is the Kafka stream thing we just set up. Now the queries here are just like what I set up for our previous attempt.
Yeah.
The difference here is this is what I was going to do next. You can go through and you can set up these dynamic query parameters. So what we're doing here is we're setting up this thing we're going to publish where you can send in a scooter ID. Maybe you just want to check the status of a single scooter ID. So here, if that is being passed in, here's that if defined. Yeah. Then we add a where clause. Same thing down. Oh, yeah, this is very different than the one I was working with.
If you want to just make a new pipe and copy pasta, that's fine too.
Yeah, that's a good idea.
We have to give it a slightly different name.
A playground. Here, we do this.
Yeah.
And we already have that name used.
Yeah, just do like 2 or something.
Okay. All right. So, and what I'm going to do here, I'm just going to copy in what our SQL was going to look like. I'll do a number 2. We'll call this get latest events.
Yeah.
Let me copy in what that was going to look like. So again, this is of course going to look familiar, but what I've done here is added that dynamic parameter for this for the scooter ID. And then we have our next node, which again is going to pull from the one before it. Oh, didn't take. I want that to be at least events. All right, so let me just copy in what this one will be. This, again, is where we're filtering for batteries. And again, here I added that as a parameter. So when you make calls to this, you'll be able to say, hey, I only want results for batteries over 10% or over 50%.
Yeah.
We'll run that. It helps if you spell these correctly.
That's the hardest part with live coding.
Let me check a few things. Get latest events. Let's call this filter. I'll just shorten it. Filter by battery.
Love it. And I want you to notice what Jim's doing here too. Jim is setting up his filters first and second. We're trying to filter as many queries as humanly possible. Like with any SQL, the key to writing fast, efficient, affordable SQL is to try to filter out as many results as humanly possible before you start doing complex queries on it. So we're trying to just like get the exact amount of things we need before we start doing creating our API endpoint from it. We've got the latest events, and then we're filtering by batteries. Which ones are available?
Yeah.
Yep.
One other thing I'm going to do is, see here. Well, that's interesting. We only have 72 megs processed. I'm going to go look back at our.
Which is the one your scooter telemetry events? Yeah. Okay.
Interesting. But the main thing here is we're seeing that we're doing a full scan. So right now we have 1.4 gigs in our main live stream data source.
That's right. It's like querying everything. Yeah.
Okay.
Yep.
What I don't get here is not pulling in any results from. I'm going to lower this to say 20%.
Sure.
Okay, there we got some results. Awesome. Now for the final endpoint, let's run that. Just make sure that looks good. Okay, so here we have our 10 closest. And what I did here for this query is, again, I made the location of what we're passing in dynamic, so the user lat and the user long. And also we're passing in a num results. So the user can say, hey, I just want to know the 5 closest or the 20 closest. They can do that. So then once you have this last node available and ready, I'm going to create an endpoint from it called endpoint.
Endpoint is just like a best practice. It makes it clear that it is the endpoint from it.
Exactly, because imagine I had like 10 different nodes here listed. Endpoint's just a nice, convenient convention to know which one to select. It doesn't have, it can be any name you want.
Exactly.
So we just published this, and the magic there is many things. One is once you publish the API, you get all these stats about incoming requests. So when Joe plugs this version into Retool, you're going to see the requests coming in here. We're going to get information about how much data is processed, etc. It sort of self-documents itself. It has picked out all those dynamic parameters that I added into my SQL. So it knows about battery threshold. And so this is like basically auto-generated documentation.
And more than that, we actually generate Swagger endpoints for every API endpoint you create on there too.
Yeah.
It's fully self-documenting. The more descriptions you write into those dynamic parameters, those all appear in Swagger on those endpoints, which is sick. All right, cool. Jim, should I take it from here?
Yeah, why don't you?
Thank you very much. Let's see here. I'm going to pull you, and I'm going to push my screen up here. So this is the same thing. We're back up here. We see Jim's dynamic parameters. View API. And you can actually see the Swagger button down here if you want to open it up and just like see that Swagger endpoint. So you can share that with your team. And it defines all those dynamic parameters on the API endpoint. So it makes it super easy to share. All right. The other thing too is oftentimes you want to see like any sort of amount of data processed by API endpoint. That's really useful for diagnosing like where expensive queries are coming from. I usually go here first to try to diagnose and see which ones are, but this average data process makes that really easy to see what's going on there. Okay, cool. So, the other thing I want to point out too that I just learned about is that our API endpoints publish to JSON. Every API endpoint on Earth does, but it also, you can publish to CSV files, NDJSON, and Parquet. There is a size limit on the CSV files, but the way around that is to use pagination with dynamic parameters and then pull that to get all the CSV data out of Tinybird. But if you want, you can also pull out of NDJSON, like unstructured JSON data or Parquet data, which is pretty handy. Oh, and then we give you the endpoints here. It just changes the data format here. But since we're building a web application, we want JSON because that's the data format of the web. I'm going to paste this into the browser just to see how this looks. But as expected, that API endpoint just returns the data from that SQL query endpoint that Jim just published. Okay, so we probably want to start using this data. Otherwise, it's not super useful for us. So we're actually going to be using nearest available scooters to build out our front-end application. We're going to be using Retool today. I have just a skeletal app here, nothing fancy. I like Retool. It makes it really easy to just like build and publish quick prototypes, or if you're doing internal apps, this can also be really useful. If I was building out like a user-facing app, I don't know if I would use Retool today, but it could definitely scale up to use that. I've been using a lot of Svelte and Tremor recently, and charts.js actually I've been using a lot recently as well. But besides the point, what we need to do is actually get this data on here. So we have Las Vegas mapped out on here. We want to start showing the scooters on the map from Tinybird. So let's go ahead and do that. To do that in Retool, you have to add a resource query. And let's see here. Can I do just an API REST query, REST API? This is my favorite part about Retool. If I paste in my query here, my GET response, it automatically parses out the URL parameters into the query. So look at that. I just pasted the GET response here, and it automatically parses out all the URL parameters and makes it super easy for us to get all that data.
It's probably my favorite feature too.
It is amazing. Okay, great. And I just hit GET query, and boom. You see all the data on there. Next thing we need to do is I'm going to do a delay between runs. It looks like it's running every 750 milliseconds. I'm just going to switch that to once a second. But you can switch it to whatever you feel comfortable doing. And let's see here. Next up, we need to go ahead and kind of translate all that data on here. So where is it on here? Points. Okay, so we have nearest scooters.data.data. So I think I need to change this to how Retool works is it uses the name kind of to identify the query. So we'll just do nearest scooters. And now this is green, which is a great sign. And it should pop up on here. So let's see where that goes. The other thing I'm going to do too is paste in the user lat long on here. That allows you to query all of the points on here that we can see on the map. So user latitude and then user longitude, because that might be the reason why we can't see it, because it's not pasting in the right coordinates. All right, cool. Save and run. All right. Sometimes it takes a second, but it should be popping in though. So it's gonna be passing in the queries on, or the lat long on here as well. So get location.
Right. And you're making a request to the _2 version.
Yes. Let's double check. Yep, looks like it is the user
awesome.
2 version.
Great.
Good point. Let's see here. Where might that be coming from? We see the data on here, but it's not showing up on here. I wonder if it's in a different location. No, it should be. Let's see, it should be on there. Gotta find Vegas again. All right. I'm going to see if these are close to the lat long that we're at on here. I wonder if there's a way to do that. Okay. 36.25. Yeah, those look close. And the longitude is at -115. Yeah, these are in the ballpark here. Why aren't these showing up?
And I checked on the endpoint side and the TinyBird side, and there is data being returned there. So
yeah, it looks like it should be in the ballpark here. Yeah, weird. Okay.
I mean, I could continue with the optimization while you take a look at that.
Yeah, let's see here. Yeah, we can do that. Yeah, because the data's flowing through where it's returning on the query. Maybe I'll queue you up then, Jim. How about that?
Okay.
So as Jim alluded to earlier when he was talking, is that his query is doing a full table scan. We give a warning here, like, whoopsie, you're querying 1.5 gigabytes every single time you query this file, which is going to like make you query lots of data and could get expensive really quickly. And this is a really common like 102 level use case for this, right? Where you're like, you build lots of simple queries and then you find out, whoops, I'm doing full table scans. I need to actually, we're processing a lot of data here. How do we make that faster?
Here we go.
Yeah, great.
So one thing to note here is I'm going to zoom in a little bit. There
we go.
We're pulling tons of data. We're you can see here we're pulling in 2.5 gigs per request. That is not a great outcome. The other thing is each query is taking nearly 1.5 seconds, which is not ideal either. So what we're going to do is we're going to build a materialized view, which is going to solve a lot of these issues. Let's talk briefly about materialized views. TinyBird is built on top of ClickHouse, and ClickHouse has an implementation of materialized views. What they let you do is scan much less data. The key thing there is data, your queries, the stuff in your pipe are applied when the data arrives rather than at query time. So you can imagine a scenario where you have tons of data coming in and you also have thousands of users. Rather than doing all the work of rolling up data, aggregating it, filtering it, what have you, every time a query comes in, it can, ClickHouse and Tinybird can manage that data when the data is ingested. So you basically just do it once and then it's available for however many requests are coming in. And Materialized Views, what they do is they generate a new data source that then you build your endpoints off of that more streamlined, efficient data source rather than your raw data. So there's really two components when you build a Materialized View. There's a pipe, and I'm going to build that in just a second. And that pipe will transform the data and feed it into a new data source. So what we're going to do, we're going to build that process, and then we're going to update our queries to pull from that instead of the raw data. So I'm going to go back to...
Also, I got retools working. I just refreshed and it worked.
Oh, good. Cool. Yep. So going back to our, I'm going to create a new pipe here, and I'm going to call this get, just make up a name here, get latest status MV, just to give me some sense of what this thing is. I'm going to, here, I'm going to slap in a query here. It's going to look very familiar to you. What we're doing here is we're going to our raw landing table with all the event data.
Yep.
We're sorting by timestamp and picking the latest for each scooter. And again, I'm getting this warning. You're scanning the whole thing. That's fine. We're about to take care of that. I'm going to do one other thing. Rather than pull all of the data, or all of the attributes, I'm going to fine tune the things I know that our end app is going to use. And watch this last number. It's probably going to decrease quite a bit.
Oh, wow.
Yeah, that alone went from 78 megs per call down to 42. So that's a good sign.
Yep.
I'm going to rename this. What should I? I'm going to call this. Make latest status MV. So I'm going to run that. And then I'm going to come here, instead of publishing an endpoint, I'm going to create this Materialized View. And this is where I'm building, I'm going to call the data source that is going to create latest status MV.
And let's see here, Jim, this might be a good time. Alexis was just asking, he'd like to understand the different types of Materialized Views.
Okay.
I wonder if you...
if
you can, great. If you can't.
Yeah, right. So here is a UI that's just like making the data source, but in fact, in this way, we're making a data source where, again, you can come here and you can select what your sorting keys are.
Yeah.
I'm going to leave those three. Those look good, but I'm going to come here to the Advanced tab, and I'm going to make some changes here. I'm going to be using a different engine called a replacing merge tree. And I'll show a graphic in a minute that kind of helps illustrate what the heck that is. But I'm going to do a couple things here. I'm going to change this engine to replacing merge tree. I want my main sorting key, because in this case, I want to pull back just one report for each scooter. So basically, we'll have a table of roughly 5,000 because we have 5,000 scooters. I got to add one thing here because of the replacing tree detail, engine version. And this tells me what attribute I want to basically sort by. And I'm telling it timestamp, which tells ClickHouse, hey, when you're making decisions about which one to keep in the table, I want to always keep the most recent report. So I'm going to set that. I think we're good to go here. I want to bring in all of the data. It's kind of like when you build a data source from scratch, you can kind of fine tune how much data you want to start with. I'm going to create that view. And if I come down here, here's and voila, I have this 5,000K table. So
how many rows did that save us, Jim?
Well, we went from like 17 million in the raw table down to 5,000.
So you're telling me like every time we query that now, we don't have to query 2 gigs of 17 million rows of data. We only have to query 5,000 rows of data.
Exactly. And we'll see the results of this in just a second.
Cool.
So here's a simplified view of what's going on with materialized views. You have like this large block of data, which is stuff you've already processed. That would represent 99% of the data in our case. But then you have these new quote unquote shards coming in of recently arrived data. And then behind the scenes, this is sort of a lazy process, but every few minutes, it goes to work and unifies all that data into the current view. And then when you make queries, it triggers this process basically. So in real time, you're getting this up-to-date view, but at the same time, you're only processing a small percentage of the data. Like the large, vast majority of it, say 99% of it, has already been processed. And this particularly makes sense with a lot of use cases. You want to build minute, hour, daily roll-ups. Maybe you're doing like sales data or user interaction data. The fact that it's maintaining these time aggregates as data arrives rather than query time just makes things so much faster. You asked about different ways of setting up these. And again, I'm using this replacing merge tree. And again, because of the way I configured that, as it's building the unified view of the data, we told it to always pull the most recent for each scooter. So you might have a couple status reports come in for a given scooter, but when it goes to maintain that table, it's grabbing the most recent. So let's go back to this. So I have this new data source, and I'm going to make just a simple change here. This was our pipe that did, again, was pulling or is doing full table scans.
Yep.
What I'm going to do here instead is I'm going to do a from to the one we just created. And I don't need any of this because we're pulling that.
Yep. Yeah, looks good.
So we went from, I don't know, it was like 50 megs at one point down to now we're in the kilobyte range.
Yep.
And the time that we took to make that query is now 0.9 milliseconds rather than a second and a half. So I'm going to run that. And then this other table, again, these are already set up to pull from the. So now when we go back to the Retool app, it's now pulling from this more efficient setup. So why don't we flip to the Retool app and see the scooter locations?
Oh, yeah. Jay, want me to do that?
Sure.
Scooter location. There we go.
I'll let you.
There we go. So I haven't changed anything on the front end here. I just did a refresh to get it to work. Boom. But you can see the scooters on here. It's still pulling from nearest available scooters 2, which we did. We created over here.
Yep.
So we like from the front end, like MVC format, right? Like the view layer hasn't changed anything. We've changed this massive thing on the back end with the model way using materialized view instead of doing full table scans. But from a user perspective, the only thing they see that changes is that it runs faster now. We're able to run those queries, and it's much cheaper and easier and scalable to do on the front end here. But see those popping up on here, easy peasy. Dang, you did that so fast, Jim. That was awesome. Well said. I know materialized views can be tricky concept, I think, for people coming into Tinybird or kind of handling real-time OLAP databases. But they're so powerful. They're so powerful, and like especially for like scaling up massively. Highly recommend looking into using those. So, great example. I love it. We only have like 5 minutes left here. I'm wondering if it might be useful. I could do a little bit more work on the front end here, Jim. We could answer some questions. If anyone has any questions, those will take precedence. So feel free to post those on there.
Yeah. Right now I'm answering the question about different use cases for materialized views. Let me just finish that.
The thing I can do too is actually connect in S3.
Oh yeah.
That may be good. I'll just show that on here too. I don't know if we're gonna have any time to build any pipes from that, but worth a shot here. So same deal. We're gonna build out a new data source on our application, and we have a native S3 connector. I've already set up my S3 bucket and set up permissions for it. If anyone's ever built in set up S3 before, it's a nightmare to get permissions set up correctly. I am not an IAM expert, but every time I got to go in there, it's always I always learn a little something new about security. So anyway, I have our S3 connection set up, and we need to set up our path to our bucket. So I have our S3 Tinybird demo data. And then I'm just going to do a star.csv and hit preview. So it's going to find all of the CSV files saved in this bucket. And woo, we got our scooter info.csv file in there. So I'm going to hit next. And I'm just going to do on demand. This data doesn't update very often, but if you're using S3 as a data lake and the CSV file is updating, go ahead and hit auto ingestion. You can set cron jobs on there to update on whatever schedule you feel comfortable with. But my data, I'm not piping any data in, so I'm just going to ingest that data once. All right. And this should be our scooter. Their scooter, we call this like scooter. What I don't know. We call this like scooter info.
Sounds good.
Cool, but same deal. We have all of our key value pairs. But this is just kind of like information on our data warehouse about our scooters. This is a really common use case. I see this often by using data warehouse data that doesn't change very often and combining that with data coming in from Kafka. Right? Because our scooter make, model, and purchase date, right? When we get the data, we'll just enter that in our data warehouse. Probably not going to change very often. We might be buying big fleets, but we can update that as needed. This is and then hydrating that data in real time. So we have all this scooter telemetry data, and using this, we can do a join on our info and get more expressive APIs using real-time data streams and data saved in a data warehouse. You can pull in data from any data warehouse, but we natively support S3, Snowflake, and Google GCP's BigQuery. So if you're using those, super easy to use out of the box. All right, anyway, hit create data source. And the cool part is since it's just raw SQL, you can just write expressions that are going to you can just do the left join on that data to get data out of that. I think we have an example. We have 2 minutes left here today, so I'm not gonna have time, but we can just use get events. I'm gonna do that new one that we have on here. So select star from get new latest events from S3. And it should not get latest. Sorry, it's get. Let's see here. Let's do we have one with the? We might have one ready to roll here, but you can just do a left join on it and it should be ready to roll. But yeah, I think we're out of time here today. Should we handle any more questions? Jim, you want to any questions look interesting to you on here?
Yeah, let's go back and catch up there.
Yeah.
One thing about aggregating merge trees, those are key. That's the engine you should use when you're using.
Wait, can you pop the question up? Which one are you
asking about? Did that do it?
Yep.
Yeah. Aggregate merge tree, that's a key one when there's a set of functions, again, based upon being built on top of ClickHouse, where when you're working with materialized views and you're doing aggregations, say you're doing stats, averages, means, maxes, what have you, standard deviations, when you're wrapping those into a materialized view type setup, you need to use that aggregate and merge tree. That will make it so when you make those queries, you can read about it in our docs. It's these merge and state functions that will always generate basically a query time, make sure it's pulling all the recent data from the different temporary tables that are being managed under the hood.
That's right. If you make a query on a materialized view, sometimes you make it like weird little symbols.
Yeah.
And that's because it's like managing the state of it, and then you have to use these aggregation queries to kind of get the final result from the materialized view.
And there's a question about the NATS Jetstream data source. That's one I'm not familiar with, but bottom line, we're always interested from our user base. Where does your data live, and what kind of native connectors do you want? So we should add this one to the list.
Yeah, and oftentimes too, we can still hook into data sources too, using either the Events API or connecting up to things like CDC on different data sources too. If they support like an op log, you can usually hook in and start streaming that data into Tinybird as well. I'm with Jim. I've never heard of NATS Jetstream before, but we can check with our ingest team too and see if it's on the roadmap at all too. Oh, we got Alistair says,
yeah.
No plans yet, but we'll take note of it. Yep, absolutely. One last one here I saw was, how do you currently authenticate from Retool to Tinybird? Which options are there to use authentication from Retool itself? I don't know. Jim and I aren't Retool experts. This is actually the first week I've used Retool. So
yeah,
don't consider me an expert. I can speak on the authentication side from Tinybird in the APIs to Retool. Which maybe I'll just
I was going to say, as that token, for example, that we copied in the Retool, that is basically a read token for that endpoint only. So it's pretty restricted in what it can hit there, which is a good thing.
Tinybird we use token-based authentication. So you can fully manage, get the read-write permissions per pipe and data source, which is, so you can control which app and users can see what data using these. Another common use case is to put another API layer on top of it. So you can rebrand it as your own API, like your own domain name, and then set up additional authentication on top of that if you want as well. But for Retool, it's an API. So you have to use API-based authentication protocols. But ours is a token-based authentication that we just pass that over as a URL parameter or a header. But to Retool, I think the Retool does support SSL, but I'm not sure. I'm not exactly sure.
All right.
Okay, cool. Let's see here. I think that's it for today. We're out of time. Time flies when you're live streaming and having fun too, which is great. If anyone has any additional questions, Jim and I will be hanging out in the Tinybird community Slack channel. You can go check that out. I wonder if do we have a banner for that? We do. Join our Tinybird community at tinybird.co/community. You can join our Slack. That's the best place to ask questions. Our engineers, Jim and I, our whole DevRel team is on there, and get support, ask questions, especially if you have more complex stuff, just getting started. We'd love to see you there. I'm going to post the code again one more time for this. In chat. So if anyone wants to go check that out, go there. And the last thing I'll say too is if you like hang out with Jim and I, we'll be doing lots of live streams in the near future. We're this is the weird in between event season, so Jim and I are going to be doing lots of streams. So you'll probably see more of us. If that's great, I'm so happy for you. If you don't love us, I don't care. That's fine. But go follow us online too. We're on. I've been doing most of my posting on TikTok and Threads these days. You can find me over there. And Jim, where can people find you?
Yeah, I'd say I used to say Twitter, but now I'd say LinkedIn and Threads. I'm also on Blue Sky. Twitter and Blue Sky, I'm under Snowman. With Threads, I'll type it in.
Yep.
Jeem8, something I made up years ago on Instagram. Now I wish I would have grabbed Snowman at the time, but it's probably already gone.
Too late. Anyway, too late. That is a good one.
Or Jim Moffat in LinkedIn.
I love it. Well, go check us out over there if you want. Otherwise, thank you so much for joining us. We'll be live streaming again soon. If you have any questions, please reach out. And it's been a blast. Jim, thanks for showing me about Merge Stream Playgrounds today.
All right. Well, thanks for joining me today. So thanks, everybody.
Right. Bye, everyone.